we started to learn about how to solve recurrence relations. In this video, we'll discuss solving recurrence relations using telescoping sequences. Telescoping refers to the phenomenon when many terms in a large sum cancel out, so the sum telescopes. For example, let's say we had 2 minus 1 plus 3 minus 2 plus 4 minus 3. And we just keep doing this all the way up to plus 100 minus 99 plus 101 minus 100. Well, what does this equal? This is just, well, negative 1 plus 101, which is just 100. Because every third term looks like 2 plus negative 2, which equals 0, and then 3 plus negative 3. You can see here, this 3 cancels with that negative 3, that 2 cancels with that negative 2, and so forth. And they all kind of cancel. We can use this behavior to solve recurrence relations. Hey everyone, real quick, I just want to mention that this video is a part of a whole course that I made. You can find a link to this entire course in the description below, and make sure to click on that subscribe button. Let's start with an example of solving recurrence relations. I have here actually a particular example that I want to pull up. This says, solve the recurrence relation an equals an minus 1 plus n with the initial term a naught equals 4. To get a feel for the recurrence relation, let's write out the first few terms of the sequence. So the first term would be 4. The next term would be 5, and then 7, and then 10, then 14, and 19, and so on. Look at the difference between the terms. We notice that a1 minus a naught is 1. You notice that a2 minus a1 is 2, and so on. The key thing here is that the difference between terms is n. We can write this explicitly that an minus 1 is n. Of course, we could have arrived at this conclusion directly from the recurrence relation right here by just subtracting an minus 1 on both sides. Now, use this equation over and over again, changing n each time. We get a1 minus a naught is 1, a2 minus a1 is 2, a3 minus a2 is 3, an minus 1 equals n. Add all these equations together. This is the clever technique here. We're going to add, and I'm actually going to write these out all next to each other. We have a1 minus a naught equals 1, a2 minus a1 equals 2, a3 minus a2 equals 3, all the way down to, I'm going to give myself a little bit more room here, an minus 1 equals n. So I'm going to write out n of these expressions here, these equations rather. And what we're going to do is we're going to add all these equations together. On the right side, we get a sum. We add up 1 plus 2 plus 3, we get the sum 1 plus 2 plus 3 all the way up to n. We already know this can be simplified to n times n plus 1 all over 2. So this is just n times n plus 1. I need a lot more room here. All divided by 2. What happens on the left-hand side? Well, we get A1, I'm going to need a lot of room here, A1 minus A naught, plus A2 minus A1, plus A3 minus A2, plus all the way up to AN minus 1. Okay, this sum on the left-hand side telescopes. We are left, and why is it called telescoping, by the way? If you've ever had a telescope and you can like extend it or whatever and contract it, that's kind of what we're doing here. We're compressing this left-hand side here into a simple couple terms here. We're left with only the negative A naught here on the left-hand side, that term, and this term right here. Everything else cancels out. So putting this all together, we have minus A naught plus AN equals n times n plus 1 all over 2. Or we can add A naught on both sides to get AN equals n times n plus 1 all over 2 plus A naught. But we know that A naught equals 4 because that's what it says in the problem, the initial problem. So the solution to the recurrence relation subject to the initial condition is n times n plus 1, it's n plus 1, all over 2 plus 4. Now that we know that, we should notice that the sequence is the result of adding 4 to each of the triangle numbers. If you had noticed that, you would have been able to guess that AN is just that. That's the closed formula. If you had noticed that in the very beginning here, the terms 4, 5, 7, 10, 14, 19, all those terms are just 4 more than 0, 1, 3, 6, and so on, which are the triangle numbers. And so we have a closed formula for the triangle numbers. We said it was n times n plus 1 over 2, and then we could have just added 4. That would have been a really easy way of doing this, but it's important to understand exactly how to use telescoping sequences and telescoping sums to solve recurrence relations in general. Anyways, thanks everyone, and I'll see you in the next video.